Hello friends, welcome back to my channel. Today we will explore a very special topic on Python variables and data types, and that is type identification and type conversions. It is really important if you want your programming to be really solid, and this will help us to learn how to harness the full potential of data types. We will also cover type checking, which will prove very important while working with Python. We have already covered basics and advanced data types like tuples, lists, and dictionaries, etc. If you have missed my previous videos, then I would recommend you to watch them first. And remember, as always, we will wrap our discussion with a quick quiz to test your understanding and also to solidify your learning. So stay tuned till the end. And before starting, please make sure to subscribe and hit the notification bell so you never miss any of my episode or content. Now let us get started and master Python. Python type conversions. In Python, type conversion is the process of converting one data type to another data type. And this capability is important in Python because it ensures that operations are performed on compatible data types. And this helps you to avoid runtime errors and unexpected behavior. Let us see how type conversions work in Python, including both implicit and explicit methods. First is implicit type conversions. Implicit type conversions or coercion occurs when Python automatically converts one data type into another without explicit instruction from you, means programmer. This feature is built into Python and is designed to prevent data type errors during your operations. For example, if you add an integer and a float, then Python will automatically convert the integer to a float before performing the addition. As you can see, I am declaring a is equal to 3, which is an integer, and b is equal to 3.14, which is a float. And when I try to add these two variables together, then Python automatically converts our integer to float, means a will be converted to float and result will be 6.14. So this implicit conversion helps ensure mathematical operations go smoothly without type errors. You might be wondering why int a is converted to float b rather than converting the float to an integer. Actually, this behavior is based on a principle that is called type promotion, where Python aims to prevent information loss during its operations. So converting a float to an integer would involve truncating the decimal part, and that will result in a loss of information. For example, converting the float 3.14 to an integer would result in 3, losing the information contained in that 0.14 part. On the other hand, converting an integer to a float adds a decimal point but also retains the original number's integrity. For instance, converting the integer 3 to a float will result in 3.0, which preserves the value's exactness. If you want to try it, then you can also try this following example where I am declaring float value is equal to 3.14, and in the next statement I am trying to convert it to an integer using int. This is an explicit way of converting any data type, which we will see sooner. So here I am converting this floating value to an integer, and if you will print this int value, then output would be 3. There is nothing like 0.14, so we have lost that information. But now let us try this another statement. Int value is equal to 3 and I convert it to a float using float function, and if I print this float value, then my output is 3.0. We didn't lose anything. Since floats represents higher precision than integers, that's why integers are promoted to floats. But floats, if they will be promoted to integer, I will say that as a demotion, not as a promotion, because you are losing something, you are not gaining anything, you are not even preserving your exact value. So that I will call as a demotion. So that's why float is never demoted. But in case it is required, integer is promoted to float. And understanding this behavior is crucial when performing mathematical operations in Python, especially in data processing, scientific calculations, and anywhere else where precision is important. This implicit conversion ensures that calculations yield accurate results without any unexpected truncation of your decimal value. So please keep this in mind. You don't require to do anything, but you should be aware why something is happening behind the curtain. Now here comes our another part of type conversion, and that is known as explicit type conversions. Actually, why it is called explicit? Because now you are converting the things manually using some built-in functions supported by Python. And this is necessary when you need to perform an operation that requires specific data types, or when receiving input data that must be converted to your suitable format. And here Python provides several functions for explicit conversions, including int function, which we recently saw, to convert any value to an integer. We already saw float also, to convert any value to a float, but there are two more. Actually there are more, but here we are also mentioning about str, which is to convert any value to a string, and then bool, as it's very clear from its name, which will convert any value to a boolean value like true or false. So to convert data to a different type, you simply call any of these functions and pass the data to be converted as an argument. For example, to convert a string to an integer, you would call int and pass in the string. Here in this example, I am saying x is equal to 10. It's in double quotes, so it's a string. It's not any number. So it's a string. And now there is another number which is 3.14. If I want to add this as it is in y, then I cannot do it. It will be an error. So I need to manually convert this, or explicitly I need to convert this 10 to a number, and then I will add that to y. So here is how z is calculated. Z is equal to, first int is called with x as an argument plus y, and when you will print the number, means z, output would be 13.14. Then let us talk about numerical type conversions in a little more detail. Numerical type conversions, as it's very clear from their name, they offers you opportunity to convert one data type into another data type. And Python offers several functions to facilitate this conversion. First is integer conversion. To convert a value to an integer, which we have seen recently, you use the int function. So for example, x is equal to 3.14, y is equal to int x, then this way you can convert a floating point to an integer. Nothing new is here. And floating point conversion, we have already seen that you can use float function and then you pass any number data type or any numerical data type inside as an argument, and this way you can convert any number type to floating point number. Then you can also convert a value to a complex number, and for that you can use the complex function. For example, x is equal to 3, and if I call y is equal to complex on this x variable, then my output would be 3 plus 0j. Remember, in such cases, imaginary part means the number which is supporting our j part, that is always 0. And these functions simplify the process of switching between different numerical data types in Python. Now let us move to string data type conversion. You can convert different data types to string using the str function, and this function returns a string representation of the input. Means whatever parameter you pass to it, it will convert that to string if it is possible. So to convert an integer to a string, then you can call str function with argument as that particular integer number. So your output would be 10, but it's in quotes because it has been converted to a string. Even if textual representation is looking like a number, but it's a string. Same way you can also convert a floating point number to a string, and it is also very easy. Just like you were doing it to convert int to a string, you can also do to convert float to a string using str function. And again, your output would be inside quotes because it has been converted to a string. And if you want to convert boolean to a string, then same way you can call the string function on this boolean parameter or on this boolean variable, then your output would be true. Same way you can also convert a list to a string, and converting a list to a string turns the list into its string representation. For example, if I have a list x is equal to 1, 2, 3, and I convert it to string using str function, then my output would be 1, 2, 3, but it's inside quotes. So it means list has been converted to a string. Now guess what would be the output of y0? Because it has been converted to string, then output would be opening square parenthesis, not 1. Just keep it in mind. This is how a list is converted to a string. Boolean data type conversion. We have just saw how to convert a boolean to a string, but do you know you can also convert data to a boolean value using the bool function. In general, any non-zero or non-empty value will be converted to true, while 0, none, or empty values, they will be converted to false. In case x is equal to 0 and I try to convert it to boolean, then my output would be false. So if I try to print y, its output would be false. And in case x is equal to 3.14, which is a non-zero value, so my output of y would be true. So see how easy it is. Let us take one more example of string to boolean conversion. We have just saw if your number is 0, then its output would be false, and if it is non-zero, then its output would be true. Something similar happens also in cases of strings. In case you have a string which is non-empty string like a is equal to hello, and if you try to print its boolean value, then it would be true because string is not empty. But in second case, b is equal to an empty string, means there is nothing inside these quotes. So if you try to print bool of b, then your output would be false. And converting none to any type other than bool or string often results in an error. Bool and string, they both results in none, but while converting none to int, it results in an error, as you can see in the traceback, that it's a type error. And converting a list to a boolean does not raise any error such as type error. Instead, it checks for emptiness. An empty list, it would return false, while any list with at least one item, that returns true. For example, if x contains 1, 2, 3 and I try to convert it to bool, then my output would be true. And if I have empty parenthesis, nothing inside there, then my output of bool conversion would be false. And to convert a list to a tuple, you can use the tuple function. As you can see in this example, I have a list of 1, 2, 3 and if I call tuple function on this variable, then my output would be bracket start with 1, 2, 3. This is a clear indication of a tuple because lists start with square parentheses and tuples they start with brackets. And same way you can also convert a tuple back to a list using the list function. And this allows you to modify the elements after conversion. So in case you want to modify any of your tuple elements, then you can convert that to a list first and then you can do whatever modification you want. But remember, you cannot modify tuple variable. You can only modify list. So if you want to modify any element, then convert a tuple to a list. And if you want to make sure that list cannot be modified, then you can convert that to a tuple. So in this example, I have a tuple of 1, 2, 3 inside brackets, and if I call list function, then it is converting that to a list. Because in my outputs, I can clearly see that my brackets are replaced with square parentheses, which is an indication of a list. And now we come to a very interesting part, to convert lists and tuples to dictionaries. Suppose you have two lists or tuples, one with the keys and another with values. Then you can use the diff functions to merge both of them together, and finally you can call a dict method to convert that to a dictionary. We have already covered this in our episode on dictionary. If you haven't seen that video, then I would recommend you to watch that. But you can also understand it from here. As you can see in this example, I have a list of keys, name, age and city, and then I have another list of values with LIs, age as 25 and city as New York. But right now they are two different lists. I want them to be together. So I will first create a diff on these two lists and then I will call dict method on the output of diff. And if you try to print the output of my dict, then you can see that it has been converted to a dictionary. Name is clubbed with LIs, age is clubbed with 25 and city is clubbed with New York. Now they are no longer two separate lists. So my dict, it is a dictionary which has combined both of these lists together. And same way, I can also convert these keys and values separately to lists or tuple. So you can see in this example that I am converting dictionary keys to a list with calling mydict.keys, which will return you all the keys inside this dictionary, and then I call list function to convert that to a list. Same way, I can also convert that to a tuple if you want it. And you can also extract the values from a dictionary and then you can also convert them to a list. Only change is that you will call values instead of keys. And in this example, I am calling mydict.values and then converting that to list. And same way, if you call tuple on mydict.values, then it would be converted to tuple. And if you will print the output, then you can see very clearly that in first case, it is a list of LIs 25 and New York, means that is all of them are values. And then in the second case, you can see that it's a tuple because it's starting from brackets, not from square parentheses. And then this is another interesting way. If you want to convert your dictionary's items to a list of tuples, then you can also do it. So to do that, you simply call .items method. This is another dictionary method, if you remember from our dictionary episode, that it will return you all key value pairs from a dictionary. And then we are converting that to list. And if you will print the output, then you can see that it's a list of tuple. Means first tuple element is name comma alias, second tuple element is age comma 25, and third tuple element is city comma New York. Now let us come to type conversion errors. So I want to emphasize here that not all types can be seamlessly converted to other data types. Trying to convert incompatible data types, that might cause you error. For example, here x is equal to abc inside quotes means it's a string, and when I try to convert it to an integer using int function, then it will raise a value error because this string value is not actual representation of a number. You cannot convert this to an integer. Hence, always ensure that the type you are converting that is compatible with the target representation to avoid any unexpected error or any unexpected output. Overall, type conversion is a fundamental concept in Python and is used extensively in programming, and understanding how to convert between different data types is essential for writing robust and flexible code. Then let us come to type checking. Type checking is the process of verifying the data type of a variable or a value. And Python provides you with several built-in functions that can be used to check the data type of a variable. And we will discuss them one by one here. First is using the type function. Type function helps you identify the data type of a variable. For example, if I want to make sure or if I want to check what is the data type of my variable x, then you can call type on x and it will return you class as int, means it is an integer. Then another way is isinstance function. It will not return you the type of that variable or that object, but it can help you to make sure that your variable type matches your target data type. So to use it, first argument is the name of the variable or the value, and the second argument is your target data type. And if it returns true, then it means your variable matches your target data type, and if it returns false, then it means your variable does not match your target data type. So in this example, x is equal to 10 and I want to check whether it is an integer or not. So I am passing x, my variable name, as a first parameter, and then my target data type int as a second parameter, and it output as true. So this confirms that x is indeed an integer. And now this is our last topic in our today's episode, that is handling type checking error. It is important to note that type checking can sometimes lead to unexpected results. So it is always best to first check the type of the variable, and if it matches or if it matches your expectation, then it is good to go further. So let us see it by an example, which we have just recently covered, that x is equal to 10, but it is not a number. It is a string. And if I call isinstance x comma int, because I was expecting x to be int, but which is not, so it means it will output me false. And now let us convert x to an integer first, which will alter our result, like x is equal to 10 before, and then y is equal to int, and then we are passing x as an argument, and now it is a number. Y is a number, but x is not. And now if I try to run isinstance on this y with my target data type as int, so you can see that output is true. So in conclusion, type checking in Python is crucial for verifying variable data types. It ensures that your program handles data correctly, preventing type-related errors and enhancing your code readability. So understanding and utilizing these functions is a fundamental aspect of any effective Python programming. And that's it for our today's video, but our journey isn't over yet. It is now quiz time, and here are the questions. And as always, you can find the solution on my GitHub page, but I would discourage you from referring that page. Instead, I would recommend you to attempt all of these questions on your own. And in case you are still not clear on any of these questions, what could be the solution, then I would recommend you to re-watch this episode again. I want you to have complete grasp on this particular topic. And finally, that wraps up our journey through Python's type conversions and type checking. And I hope this video has provided you enough information on the powerful capabilities of correctly managing your data types in Python. And using these techniques, it will make sure that your code is not only more robust, but that is also more versatile. And if you found this tutorial helpful, then please hit the like button. It really supports my channel. And don't forget to press the subscribe button and stay tuned for our next episode where we will dive deep into Python's various operators. Now we are going out of data types. And we will break down each operator and show you how they can be used in real-world programming scenarios. Again, make sure you are subscribed and have notifications turned on so you don't miss out any of my episodes. Good questions or need more details? Then please drop me a comment below. Keep experimenting with what you have learned today about Python programming and take your skills further. Thanks for watching, and as always, happy coding. Take care. Bye-bye.